quick 30-minute session, and I'll not maybe hold you guys for long just talking about these slides. So we'll also talk about some of these industry use cases in the end, and I want to spend more time on the industry use cases when we reach there in the end, right? So my name is Anay Pathak. I am working as a senior technology consultant, have experience of more than 15 years with multiple multinational organizations within the country, and I have been associated with the industry from more than 15 years on a lot of technology use cases and trends, right? So when it comes to trends, we make sure that we are able to give best trends to the industry, and also talk about it with my learning. So whatever I'm speaking here is just my learning. It is what I have learned based on my research, and these are my personal views, whatever I'll cover in next 30 minutes. So basics of artificial intelligence is where I would cover few of the terminologies, how artificial intelligence adds to the overall theme of India Technology Week, which is IoT, right? And talking about technology, I also see a theme as green technology, right? So I mean, basically with AI ML picking up, and I'll also tell you why AI ML is picking up now, right? There is certain changes which has happened in past few years, which is leading to this enhancement, which is leading to this surge of AI and ML in technology adoption, right? So we'll quickly be covering few of the terminologies. As I said, covering AI in detail in such a short span of time would be really difficult, but you will at least get to know few of the terms, right? And you might be able to clear a few of the doubts as well. So I'll like to keep a couple of minutes for questions in the end. So if you talk about AI, right, the basic AI capabilities which you see is Google, right? If you talk about anything when it comes to the natural language processing or the ability of the machine to think before you can think about it, it is Google, where you give certain words like text in this example, and it automatically tells you talking about text mining tutorials, text mining algorithms, and whatnot, right? So that is where a lot of data is already fed in the Google engine, and this is the capability of a machine to imitate the intelligent human behavior, right? It might be wrong. I mean, machines are nowhere closer to where we are, but this is just Google trying to imitate the human behavior and giving you results based on your search, which is your personal data, as well as the data which is already fed in. If I come to artificial intelligence, why do you need it, right? And this technology week or technology forum, you have to understand the value of artificial intelligence when it comes to why do we need it now, right? It has been there since, let's say, 20 years, but it is really picking up because 61% of the organizations, we think that AI will be the more significant initiative in the next few years, right? So it was there, but I will cover why it become more and more important as we progress further. 53% we think that AI will lead the future digitization effort, and you know how important digital transformation is, and it has a 44% annual growth rate, right? So these are some of the interesting figures. If you are looking at, and if you want to learn, and if you want to think why I should invest time on AI, these are some of the interesting figures which leads to investing time and also learning about the technology. And the artificial intelligence is projected to be greater than 50 billion, again $50 billion by 2021. Why should you care about artificial intelligence? Again, you are in this technology week, you have learned so much, you have so many booths, you have so many stalls to visit. It is your relevancy with the customers. It is really relevant with your customers. You have greater margins when it comes to the AI enabled solutions than a non AI enabled solutions, and the growth opportunities which you see, which I've covered in my last slide. Now I was always telling what has changed, right? So if you see the graph of AI, you will see it is there from 1950s, and it has gone through a journey. So it was really hot, and then if you see, it has gone down in 80s, then again picked up, and then again mid 90s it has gone down. But from 2000 and onwards, I think there's a lot of development which has happened in the field of AI and ML, and one of the major reason is timing, right? So cost of compute is decreasing, and cost of compute is decreasing from 1950s to 2020 where we are, and the amount of data is increasing. So we have more data to analyze, we have more data to learn, and that is where it is a perfect scenario, maybe after 90s, where the cost of compute is further decreasing and going down to a level where we can afford high computing devices, while your amount of data keeps increasing, which means you will be able to process more data, get more meaningful results out of it, right? Just understanding how AI fits in your story, right? You might be an exhibitor, you might be attending this session. Start with an early stage, right? Just a batch oriented job scripting customization which we do is an early stage, which it is a point usage of an AI. Then think of a mid stage, which is an operational maturity, where you have really interactive and real time use cases. You talk about data lake, you talk about IoT enabled devices, and then you look at the advanced stage of analytics, where you are trying to be as close as humans, right? You cannot be, but still, right? So fast real time use cases, on demand analytics, and bursting analytics, and some of the keywords which are used when it comes to the advanced stages of artificial intelligence. What AI, machine learning, and deep learning is, right? If you don't know AI, you think AI is a separate term, machine learning is a separate term, deep learning is a separate term. This is not the case. If one thing you can learn from here is artificial intelligence is a bigger umbrella under which you have machine learning, and under machine learning, if you are able to do more inferencing and if you are able to train your system in a better way, you have deep learning. So AI would cover ML, and ML would cover deep learning is how it works. And that is where you understand the importance of having these three together. When we talk about it, it is like a bundle, and we don't talk about it separately. I mean, as I said, I mean, even I was thinking that we have two different technologies, but no. If you learn ML, it is again part of AI only, which is artificial intelligence. Difference between these three, again, different times of origin, where AI came in 50s, machine learning in 60s, and deep learning in 70s. Artificial intelligence is everything what we do coupled with IoT devices, coupled with sensors. Machine learning is focused where machines are programmed to do something, again the part of AI. And deep learning is where machines are able capable of doing something without training, which is getting the inference automatically and deriving to the results, right? So deep learning is one step ahead of machine learning process as well. So very important terms if you want to take it as a key takeaway, because this will again help you a lot when you understand the process of AI, ML, and DL going forward. There is also a Turing test in artificial intelligence. Read about it if you get time, right? So Turing test is basically a method of inquiry for determining whether or not a computer is capable of thinking like a human being, right? So if you read more about the Turing test, you'll see we often do Turing test. We often try to check whether computer has enough trained data and it is capable of thinking like a human being and giving us responses. And that's where we result the computer on the basis of the training which we have done. Some of the key terminologies I'll cover in next 10 minutes. First of all, when we talk about AI, right? And basically, you talk to your customers, you talk to your end users, be relatable. I mean, don't just talk about AI just for the sake of talking, right? Be relatable to your customers. Talk about artificial intelligence in a way so that they can benefit and they can make good use case out of it, and they can enhance their business model when they are using these artificial intelligence and machine learning in their business model. Second is understanding the key pain points to develop opportunities. You just cannot go and say that this is trending and you should use it in your business. Understand the key pain points and see where does it fit in, so that you are able to optimize it. And you will not be able to do it in one day, right? It's a continuous process. As artificial intelligence is a continuous process, you still have to invest and see if we can take it to a deep learning level. Differentiate between machine learning and deep learning, again very very important, because you need to understand that you are training machines, or you are making sure that machine is capable enough to take decisions when it comes as a part of deep learning. And last is connect to the use cases, with what you can offer, right? So a lot of things as a key takeaway for the exhibitors and other people attending this forum. Just do not pitch it just because it is like a buzzing technology or a buzzword. You need to do your homework, you need to understand it before you go forward and take it with your end customers. Some of the differences or some of the technologies which we use, machine learning, deep learning, is something which we use, and I'll just cover a quick slide on what's different between these two. Then there is something as training versus inference. You have supervised learning, unsupervised learning, and last are the libraries and the frameworks, right? So if we talk about machine learning and deep learning, as I covered in detail, and you will anyways have access to these slides as well. When we talk about machine learning, we are talking about very, very specific use cases in terms of decision tree, algorithm, reinforcement learning, making sure machine is able to do a particular task and it is trained enough to do that task. When it comes to deep learning, it is unsupervised. It is a pre-trained network, right? It is more of a recurrent neural networks where your data is already applied to the neural network with large number of layers and parameters to achieve the artificial intelligence part of it, right? So this is a difference between training the machine to taking it to the next level of deep learning. Again, if we come to machine learning versus deep learning in an example, use case one, I'm trying to train the machine on the facial recognition based on the formulas and algorithms, and then I find out this is the person which I'm talking to, right? uh, okay, let me go back one slide. Yeah. And if I talk about the deep learning process, deep learning process is basically where the model itself understands, right? Based on the data which is provided, the model itself understands and come to inference that this picture which I'm seeing is for Arjun, and it is trained enough with the number of images which has been supplied in the past, right? Again, supervised, unsupervised, as the name suggests. Supervised is basically you make sure that you are there. You're always trying to do that, and you're always trying to supervise while you are making sure that machine is learning. And unsupervised is you give the data, you give the inferences, and machine is able to do the clustering and make sure that there is generative models available, right? As this is basics, probably I would not go much deeper into these learnings, but at least you understand the key terms, right? And how a supervised learning would differ from an unsupervised learning, and you can read more about it. Last is the difference. If I keep all of them in a tabular format, with supervised learning, the machines are learning with the labeled data, unsupervised is unlabeled data, right? And reinforcement learning is basically making sure that the agent or the machine interacts with its environment, and then it produces an action, which can be an error or can be a reward, right? So you don't put in those boundaries, and you are able to absorb it as an error, which is like it is perfectly wrong, or a reward, which is exactly the same type of data which you're expecting from the machine. Some of the algorithms are also written, and the approaches, right? So, I mean, key thing is approach where you have labeled input to the known output and supervised, right? Everything is very, very predefined. Unsupervised, you understand the pattern and discover. So you basically try to understand it and get to a output which is desired. And reinforcement is purely trial and error, right? So if you go for it, you try for it, either you get the desired output or you fail, because that is where you are not making sure that it is a set process which you are following when it comes to the reinforcement learning, right? So If I move to the next slide, we also want to cover something on the neural network side of it. So neural network, as you know, this is a method of computing, and this is the way where we want to reach in the end, right? So if we understand what is neural network, this is a method of computing based on connected processing element, right? And we compare this neural network to the neurons of the human brain, right? So you feed in the data and you expect an output based on the data which is fed from multiple computers, and that is where my example of having uh, the cost of compute and the cost of or the increase in data comes in, right? So now you have so much data to process, where you can derive so much of inference that it is the right time to also get into the neural network and ensure if we are able to get machines which are very close or really close to the actual results which we are expecting, right? So if we talk about training and inference, you try to train when it is on a human or a bicycle or a strawberry, and you basically train the system forward and backward to get the differences between a bicycle or a strawberry or a human face, and that is where you train the system continuously. Inference is you have given multiple bicycle picture, you train the model backward and forward, and it will give you, is it a bicycle? And then from there you will try to probably find out that whether it is a bicycle or it is something else. In terms of image recognition, right? Machines are able to meet or exceed the human in the image recognition piece of it. The error was more than 30% in 2010, but now the error is less than 8%, and that is where the humans are, right? So machines are 97% human in case of image recognition, and that is how we have fed various models into it, right? So image recognition is easy to feed. You put in a lot of data, you put in a lot of content, machine keeps on recognizing, and it's millions and billions of images which we are talking about, right? Just make sure we are not losing any aspect, and that is where machines are able to be 97% accurate with the human recognition, or the image recognition piece of it, because now they are at a level, if you give them an image, the chances of getting it correct is quite high. I mean, we're talking about 97% person, which means very, very near to human, or sometimes more than human can do when it comes to image recognition. And then there are some libraries and frameworks, and these are used when we talk about the overall AI and ML workflows. Just putting it in my slide just so that you know some of the keywords like the Pythons and TensorFlows and cafes of the world, which basically does the analytics. Make sure that you are able to train the machines, make sure that you are able to do supervised and supervised learning and take it forward, right? So obviously these are technology in itself, these are something which you would go deep dive into it and learn about it, but just putting some of the key names in case you want to go ahead and learn about these libraries, frameworks, and different models which are available for you to consume, and for you to, I mean, you would not be able to train machine if you don't have a proper technology in place. So this is where it's a mix of technology, it's a mix of codes, and how easy we can make it for you, right? So if you talk about AWS, if you talk about Azure, if you talk about Google, all these public cloud vendors, they are trying to give you uh, artificial intelligence or machine learning in a very, very simple format. And when I say very, very simple format, we are talking about something which you can consume easily. You don't have to code a lot, you don't have to learn languages a lot, but it is available to you as a graphical user interface where you can put in the value and you are able to train the machine to get the desired result, right? So we are now even working on the simplification of artificial intelligence and machine learning so that it can be used and adopted by everyone in the industry. Coming on to the use cases and example slide, where I want to spend maybe 4 to 5 minutes before I take the questions, is all these industry verticals and everywhere we use it, right? So healthcare, we are using IoT devices to train the nurses and doctors in today's scenario, right? And we are talking about AR, VR as well. So augmented reality or virtual reality again comes coupled with your AI ML inbuilt. So all the AR, VR, and IoT use cases in the healthcare. Another IoT use case in the healthcare is if you can have a sensor fit in your health devices, which can report more than what it does. You have Fitbits, you have Apple Watches, which just give you pedometer, distances, heartbeat, but right. But what about if it reports more data and more accurate data with the sensors available, and it is always connected to your doctor, where your doctor is able to get the data for last 15 to 20 days, is where IoT coupled with AIML helps you in the healthcare side of it. Coming on to the financial services, I mean, in this connected world, security is key, and you need to make sure that you are able to do fraud prevention and digital assistant and network security in the financial services domain. And AI or machine learning, I always say AI and ML because both are related, plays a very important role when it comes to digitalization, digital payments, cashless transactions. All this is done from the inferences and training which is done to the model to avoid fraud, to make sure it is a more secure transaction as it goes through. Government security, you might have seen multiple facial recognition video surveillance system. But what is important nowadays? Thermal imaging, right? So thermal imaging, which was used for military during the wartime, now this thermal imaging has gone to the next level, where we talk about thermal imaging to make sure we are able to get the body temperature, right? And ensure that we are able to report it correctly as well. So thermal imaging has taken a huge jump when it comes to our technology trend, and it is being used at all the airports, hospitals, or even the offices, right? Just to make sure we get a contactless experience, and also ensure that we are able to get the desired result which is required as per the government guidelines, right? So media and entertainment, it is always there, right? We talk about now having virtual conferences. We also talk about having football or cricket matches where players are actually playing in the stadium, but with the help of AR, VR, you are sitting at the home and giving a real time experience both to the people on the ground, as well as you are able to give that real time experience for yourself. So you're basically watching a match in a stadium sitting at home, and they are able to hear your cheer and excitement in the stadium in the connected world with the help of 5G as well, right? So that is where AIML and AR VR would play a major role in the media and entertainment industry. Second is NLP, very, very difficult, natural language processing, because to understand someone's language and to understand and translate with the different dialect which you have, it is one of the most difficult things to do. And we are far ahead in the language processing as well, because now you have chatbots, you have bots which are able to understand plain simple English and able to respond back as well, and we are moving in that field. Energy, you have wealth, wind, right, solar, weather predictions. So all this is coming from the data which is being fed in, the data which is being analyzed, and you are able to get the desired result, right? So all your solar forecast, oil optimization, consumer demands in the energy field comes from the AI ML capabilities and the data which has been fed in so far, right? And you might see we are getting accurate. We are getting close to accurate when it comes to the weather predictions, right? So that is where it would take time to train the system, but at some point in time, you reach that level where you are near to accurate, or you are able to predict it with, let's say, 80% accuracy, which is very good. Last but not the least, transportation. Everyone talks about autonomous cars, right? We talk about by 2021 you will have a lot of autonomous cars in there, or you will have a lot of uses of autonomous vehicles going forward. This lot of training and inference which has to be done, right? Each car which goes on for a day learns from what it has captured, and I mean, surprisingly, it is basically stored in the local hard disk. So a car is able to generate close to 60 to 70 terabytes of data in a day while it learns on one particular day, right? And there are hundreds of cars which goes, gets the data. That data is fed into a edge core cloud system for processing. And after the processing, you again let that car go away on the next day. And that process continues so that you are able to reach to a point where you can actually talk about autonomous vehicles and help them in the cause of, right? So you also have robotics, drone deliveries, all being part of the transportation. Again, AIML led. You have a lot of risk assessments and the lane tracking and the traffic patterns, again done using the data which is fed in thousands of cameras, capturing it, feeding it into a system, doing an edge core cloud processing and giving you the meaningful results. So some of the industry use cases, and these are endless, right? And I can talk about each of the industry use cases in details, but since we have just 4 minutes, I'll probably stop the share. And I mean, thank you so much for taking out time. Let me take some of the questions. Do we consider robotic is an application of AI? Thanks. Yeah, absolutely. Yes. Right. So when we talk about robotics, we talk about Sophia, or you talk about digital clone, right? And digital clone is basically cloning someone and making sure that it is able to learn from the clone. We also talk about digital clone in terms of racing cars, right? So instead of training the cars, you basically create a digital clone of a racing car. The car can learn on the track, right? Digitally as well. And the learning of that digital car can be fed into the actual car, right? So all this robotics, digital car, digital twins, and we also talk about having a clone of a human system is part of AI and ML. That is correct. Is there any work toward all production optimization till yet using AI? In terms of optimization, the work is going on, but there is a lot of work which is being done to basically find out the right place and making sure that we are able to get to right results. You know how difficult the oil production is, and basically finding out the right places and ensuring that we are able to get the desired results, right? So based on the data which is fed in, a lot of work is going on, and that was in there in my slide as well, right? That how you can optimize it, how you can make sure that you save time on it and still be able to do it in an effective manner. So yes, there is work going on. Please give some real-time examples of deep learning and how we overcome huge GPU requirements, such use cases for processing. Okay, so as I said, cost of compute versus cost of data, right? So the data is increasing and the GPU's requirement or the huge GPU requirement is much more affordable now. I know we need huge GPUs or we need a lot of RAM or you need a lot of compute when it comes to the processing when it in the deep learning. But consider 1990s or 2000. Will you be able to afford it, right? Will you be able to invest in so much of compute uh, while this becomes much more easier now and you are able to get to the result? Again, it is not very commonly available for everyone, right? Everyone cannot afford it. That is where you go to public cloud, right? All the cloud vendors, right, from the Googles of the world to Amazon or Azure, provides you that on a pay as you go model, right? If you have data, if you want to train your system, leverage their compute, leverage their data points, and you will be able to get the desired results in a much more cost effective manner, because there is no limitation of GPUs, there's no limitation of the compute which is available with these cloud vendors. So do try to leverage these cloud vendors if you are trying to get to a desired result instead of buying or investing in the compute altogether. Okay, in the chat also I see, is mathematics and statistics probability are required to solve the industrial use cases using AI and ML technology? I mean, mathematics and statistics is important, but I have covered about a lot of use cases on the algorithms, right? So all these algorithms which I discussed, all the languages which I discussed, those are important, right? So if you're able to learn those algorithms or learn the easier models available, which is provided by the cloud vendors, I think you should be able to do the industrial use cases of AI ML without even investing in the compute, without even talking about it a lot, or don't own anything, right? If you want to learn, use a cloud or use a model which is pay as you go. If you feel comfortable with it, then you own anything, get your systems and make sure that you are able to train your models. So that's for you, Shivanand.